Okay, seems like we are live. Hello, boys. Let me see if I'm live. Yes, I am. Stream looks healthy. ये सेटअप चेंज कर दिया है ना, तो सब कुछ सेट करना पड़ रहा है। आई हैव नो आइडिया कि सब कुछ काम कर रहा है कि नहीं कर रहा सही से। विल सी। वाज about to start at 9:30, but it's been like an hour to set this thing up. Frame dropped at 0. This is 6. So kbps, which is fine. Frame cool. So we are going to continue our this thing. Last time we left here. I think audio level should be fine. Cool. This thing quiet. Okay. So we will continue from here. Memory related intrinsics. Actually, the thing is, I have already done something and I already finished this chapter. So just to show you, we can sort of uh, do this. We can have this thing there, printing the hello world in the QEMU virtual machine. So the so wherever we I have completed till here, but I just still go through because I don't remember anything that I did previously. Okay, so this thing is this memory related intrinsics, whatever that means. The REST compiler assumes that a certain set of built-in functions is available for all systems. A certain set of built-in functions. Okay. Most of these functions are provided by compiler built-ins. Let me digest this. You're saying the compiler assumes that a certain set of built-in functions, the compiler needs some set of built-in functions, which just assumes that they are available for all the systems. Huh? Most of these functions are provided by the compiler built-in crate. So this is a crate that provides those built-in functions that we just recompiled. Did we? Here. In cargo.config.toml, I said, okay, okay, nice. However, there are some memory related functions in that crate that are not enabled by default because they are normally provided by C library on the system. Really? These functions include memset. So the memset, okay, which sets all bytes in a memory block to a given value. Memcopy, which copies one memory block to another, and memcompare, which compares two memory blocks. Oh, I can use this function sometime. Well, we did not need any of these functions to compile our kernel right now. They will be required as soon as we add some more code to it when copying structure. Okay, got it. We can't link to C library of the operating system. We need an alternative way to provide these functions to the compiler. Well, of course we cannot because we are writing an operating system, so we cannot assume that we have an operating system and so a C library. One possible approach for this could be to implement our own memset etc. functions and apply the no mangle attribute to them to avoid the automatic renaming during compilation. True. However, this is dangerous since the slightest mistake in the implementation of this function could lead to undefined behavior. This is the like I've been thinking about such sentences lately. What I've been thinking is that this phrase, this slightest mistake in the implementation. So, out of fear of the slightest mistakes in the implementations, we prefer to use already existing libraries. But if we are doing things for our personal use, then these this phrase should not uh, prevent us from re-implementing these things, because in software, until and unless you reinvent the wheel, you won't learn a shit. So this, I mean, I understand. Okay, let's see. For example, implementing memcopy with a for loop may result in an infinite recursion, because for loops implicitly call the into itr trait. For loop calls the into itr trait. Yes, I remember for loop calls this. How do I remember? We'll see in a minute. For loop implicitly call the into itr trait method, which may call memcopy again. Okay. So it's a good idea to reuse existing well-tested implementations instead. Cool. So let's just see how does that happen. If I go into Rust USD official docs. What is this? References? Nope. I don't need references. Rust by example. Nope. Control flow. Which is this? So I remember some time ago I read. Okay. So this is it. Is it? I don't know if I could find it again, but should be here. The for in contrast is able to interact with an iterator in several ways. Okay. As discussed in the section on the iterator trait, by default, the for loop will apply into ITR functions to the collection. However, this is not the only means of converting collections into iterator. So in Rust, we have some collections, and then we convert these collection into an iterator, and then we perform those the other options like for loop and map and all. So into ITR, ITR and ITR mute all handle the conversion of a collection into an iterator in different ways by providing different views on the data within. Okay. ITR this borrows each element of the collection through each iteration. Remember guys, we are learning Rust by writing an operating system. So we're going back and forth. Thus leaving the collection untouched and available for use after the loop. So this thing says for loop implicitly calls the into ITR trait. Okay, so it consumes the collection so that on each iteration the exact data is provided. What does that mean? Once the collection has been consumed, it is no longer available for reuse as it has been moved within the loop. Okay. So you do this, you move this data. Let's just say it is the first one into the loop. This immediately borrows each element of the collection, allowing for the collection to be modified in place. So this thing can mutate this in place. Nice. So what do? I'm doing match every. Okay. So inside this mute, I'm doing matching on this name. And, never understood this. If the okay, I get it. Okay, so This is a variable, right? If name is equals to this, so the matching happens if the type gets matched, right? Could be wrong, I don't know. So if this thing is equals to this thing, if this thing matches, then you do this. Okay, so should I open a background just for the sake of it? Because I wanna. Do I have anything like editor, simple, binding? Mm, so mm, can I have something called what I want is to have the spell check. Help me out. No, this is Chrome's. I want to know the types also. Do I have that? Clippy interpret. What the hell? Okay, yes. New or what? Cargo new. Test cannot be used as a package as a configure. Okay. Test snippet. So npim test snippets. What was the key binding for this thing? Oh, invalid line offset column. This is what are you talking about? Oh, what, brother? The fuck, brother? Okay, so how do we do this? How do we do this? No, no, no. What is the key binding? H. Just search key binding. What was it? Yeah, so DOCS docs. Where was the docs LSP document? Something like our K. Yep, not K. No information available. Yeah, so the name is of type. Hold on a second. So this thing to be equal this thing, right? And I can read the the match statement, right? Is this the or Rust by? It is Rust by example. Rust provides pattern matching via match keyword. Okay, which can be used like a C switch. The first matching arm is evaluated and all possible values must be covered. This thing is fine. Tell me about this. For pointers, a distinction needs to be made between this destructuring and dereferencing, as they are different concepts which are used differently from languages like these things. Dereferencing uses this, destructuring uses. Oh, I didn't know that. Oh. Dereferencing uses cool. I mean, this is fine. Destructuring uses. Hold on a second. Sorry about that. Destructuring uses okay this ref and ref mute. What is destructuring? Let's just see in here. Assign a reference of a type I32 with the ampersand signifies there is a reference being assigned. Okay, reference is here. If reference is pattern matched against this percentage value, sorry, ampersand value, it results in a comparison like this. If reference this is pattern matched against this, it results in a comparison like this. We see that if the matching ends are dropped, then the I32 should be assigned to value. Then I32 should be assigned to value. I don't know where did these two come from. So you are saying if reference is pattern matched against this thing, it could be any. Okay, so it results in a comparison like this I32, which is okay. So reference is pattern matched against this. Mm, results in an X comparison like I32. This you see that if the matching this are dropped, then the I32 should be assigned to value. Cool. Yeah. So in this case, where does this come from? I match reference with this thing and And if I drop this ampersand, then this value should be equal to this, which is an I32. And then got a value via destructuring. Yeah, I can understand this much. So cool. So to avoid this, you dereference before matching. To avoid this, you dereference before matching. So what you do this. That means you okay. So that was the reference. Now you get that value. Ah, makes sense. Sense. What if you don't start with the reference? Reference was a and because the right side was already a reference. Reference was this because the right side was already a reference. This is not a reference because the right side is not one. You lost me, brother. This is not a reference because the right side is not one. This one, nah. Like not a reference. Yeah, it's a value. First provides a ref. Oh, wait a minute. What if you don't start with the reference? Reference was a this because the right side was already reference. Was a reference because right side was a already a reference. So right side was already a reference because of the and sign, because of the ampersand sign. So that's why it was a reference. So this was a reference because right side was already a reference. This is not a reference because right side is not a reference. So not a reference is not a reference. Not a reference, not a reference because of this three. This three is not a reference. So the right side is not a reference. So this variable is not a reference. Rust provides a ref for exactly this purpose. Okay, so it modifies the assignment so that a reference is created for the element. Uh, so okay, so let me rephrase these things. This was a reference, so you put ampersand before that. If you do this, you can get a value and then you can drop the ampersand. What if you start with something which is not a reference, but now you need a reference? For that, you have this. See, so the opposite of this thing. It was a reference, but you did not want to have that ampersand here for some reason. So you dereferenced it. So the opposite of dereference is this reference. So if something is not a reference, then you can get it as a reference using this ref variable, ref keyword. It modifies the assignment so that okay, so it used in assignment. Of course, it is going to be used in assignment. It modifies the assignment so that a reference is created for the element. This reference is assigned. Now this is a reference. This is a reference. Accordingly, by defining two values without references, references can be retrieved via ref and ref mute. By defining two values without referencing. By defining two values without references, it is value reference can be retrieved via ref and ref mute. Ah, so this one is for only references of a variable which initially defined as unmutable, and this is for variables which was initially defined as mute. mutable. So this is a value, this is a mutable value, and we use ref keyword to create reference. So if I take this value, and match with this, so R has to be what, reference? Got a reference to a value just because I'm matching as a reference. Use ref mute similarly, ref mute m. I'm curious what this is going to be. What did you say? Oh, yes, it is intentional. Help remove mute. No, will not. Got a reference to a value 5, which is that value. What is the type of this thing? Why it is you're basically saying R is a reference to I32, but then in that case, what is the value of this? Okay, so you're taking matching. I don't understand. So the type doesn't have to be matched in that case. Let me tell you what is bothering me. So initially I thought that type of this has to be equal to type of this, only then the matching will happen. But apparently that's not the case, because you can see type of this is I32 and type of R is going to be reference to I32 because I'm taking it as a reference. I'm using the ref keyword. The type is a reference to I32. But in that case, what is this guy is going to do? Um, Definitely a mutable variable. This is a reference to mutable variable, and then you can. I don't get it, man. In this case, what is going to happen? Why are you slow, brother? Using UVM for the exact reason, and you're still slow. Like, the type of this is definitely going to be reference to I32, and so oh, kidoki. Value is going to be I32, and this is definitely going to be reference to I32. So in this case, the type is being matched. So you are saying if the result in comparison like I32 and well, we see that if this is dropped, then I32 should be assigned to value. um, which is this I32. This is I32 should be assigned to value, so the value would take the value of this thing. So if mute, type of mute is I32, let's take this one. Type of value is I32 and type of R is reference to I32. It says some these lines. Exactly this for it modifies the assignment so that a reference is created for the element. This reference is assigned. So if I say this, you're saying a reference is created for this. I just did. It's an I32 ref. Can't get my head around. I'm supposed to understand pattern matching then. Reference is a type this, the value will get this 4 value because of the exact reason that this guy said here. Because of the exact reason that this guy said here. And what about that thing? So the type of this is definitely I32. How am I supposed to understand this? Hmm. Should I understand this using some like assignment thing? But forget this mute thing because mute thing is a little bit complicated. I'll say, let's just say type of this is I32 true. Type of R is a reference. So let ref call it URS. Can I do this? Okay, I can assign. You can clearly do that, brother. This is what this is. If this assignment can happen, means I can assign a value to a reference. No, you are creating a variable and then saying that this variable doesn't hold this value or own this value. It just has a reference to this. It will live on some memory, true, obviously, and this thing will have reference to this only, readable reference. Right. Similar thing is happening here. So you have a value which is I32 and you are saying that R is going to have a reference to that. So type ID, what does that guy do? Type ID. got a reference via. I'm trying to print the type here, but I cannot find it. Does Rust have something? Where is ChatGPT? Mm, better ChatGPT. So get a type of a variable Rust. Print type. Type takes in. So type name standard any name. Okay, so it belongs to standard. Great. Type name T. Uh, type name. So I have to provide. I don't think this work. This would need to be constant. Okay, attempt. How is it using? So you're passing the type in here, and then reference of bool. So it's a type, not a variable. So, but I'm passing a variable name, so that would not work. I had to be quiet because of the noise. Sorry about that. So this thing is, let me just type it and see what happens. I'm just trying to understand it, but I cannot print type. Print type pass in the reference, which is R. If R is a reference, then which R is actually, then this should print the type thingy. Where's my cursor? Where's my fucking cursor? How can R be of type 30? Brother, this thing is of reference to either. How can you say that? Okay, so the destructure, when destructuring happens, I don't understand this thing, man. Let's get back to this thing. This is just to we're getting sidetracked, boys. But I have to understand what is the official book says. Where is pattern matching? Match control for a construct. Well, let's break down the match in the. First, we list the match keyword. First, we list the match keyword by an expression. So, match keyword is this. This is an expression, okay. Man, this noise is just killing me. The external noises. Okay, so if I had forgotten this thing that these things are expressions. This seems very similar to a conditional expression used with if, but there's a big difference. With if, the condition needs to be evaluated to boolean values, but here it can be any type. Okay. The type of coin in this example is the coin enum that we defined on the first line, which is this thing, true. Next are the match arms. Arm has two parts, a pattern and some code. This is pattern and this is some code. Why am I learning match here? Because we went to hunt why this is the case. Then we okay, I'm getting sort of sidetracked, but I think this is the point of learning Rust. I guess that's how you learn, by doing it. Oh man, what are you gonna do? And life is hard, brother. And then this operator that separates the pattern and the code to run. The code in this case is just a value 1. Each arm is separated from next one with a comma. When the match expression executes, it compares the resultant value against the pattern of each arm in order. If a pattern matches the value, resultant value, so the expression results in a value. Man, if the pattern matches the value, the code associated with the pattern is executed. If that pattern doesn't match the value, execution continues to the next arm, much as in the coin sorting machine. We can have as many arms as we need in the listing. Okay. So the pattern evaluates to a value, expression evaluates to a value. In this case, the value is of type I32. I still don't see how I32 would match reference to I32. No problem. Let's move forward. We'll learn. Hmm. I'm ahead in the time, I guess. We were here. Fortunately, the compiler built-in crate already contains implementation for all the needed functions. They are just disabled by default to not collide with the implementation from the C library. We can enable them by setting cargoes and build features flag to compiler built-ins mem. Of course I did. Oh, this thing I don't understand. But I can't find this thing, man. We did have which is compiler built-in mems, standard is core and compiler built-ins. It was added only was only added very recently. So you need to okay. Behind the scenes, this flag enables mem feature of the fact. This is that No manual attribute is applied to memcopy implementation. Ooh la la. Destination source. Destination source constant enter table. You give me this. This is good. I would want to do these things one day, but I don't know, that day might not come or come. I don't know. Brother, why so negative? Okay, so with this change, our kernel has valid implementations for all compiler required functions. School set default targets. So this is just sets the targets and then printing something to screen. I already did that. Okay, so easiest way to print is the VGA buffer. So what is this piece VGA buffer? Let's just see what's this piece VGA buffer. This is VGA buffer. Text buffer. Each screen character is represented by 2 bytes aligned as a 16-bit word accessible by CPU in a single operation. Okay, okay. I mean, this is a topic in itself, and there's some buffer that we're going to print. This and in the next post we'll okay, where we write a first small driver for it. For printing, however, we just need to know the buffer is located at an address this, and that each character cell consists of an ASCII byte and a color byte. I as I size multiply by 2 byte. So the thing what the rust by example. Nothing was rust by example. The destructuring happens with this and this, and the dereferencing happens with this. So this is basically dereferencing at this offset and then put the value there. Okay. Similarly, struct can be destructured as shown. This is your struct who there was a rat in my house. Small one. Foo is an expression which is this one, and I'm destructuring it. So I'm evaluating these two, and then the x would be this one, and so b would be 2 and y would be 3. You can restructure structs and Rename the variables. The order is not important. 2y2 x1 print y is 2, I is x, which is what is x? Before I play this, should see that x is going to be a tuple. So x is going to be 1 and 2. Right? First of all, x is 1, b is 2, y is 3. Order is not important. Which one did it match? X 0 is definitely going to be this. Y 0 definitely going to be y. Okay. What regards? Match guard can be added to filter the arm. The type is Celsius 30 with value 35, temperature Celsius, some value T, so it will pattern match. This temperature is this type and matches it with this. Destructures it into T will become 35. If T is greater than this, then you do T condition part is the guard. Okay, if 86. Another compiler won't take guard condition into account when checking. Note that compiler won't take guard conditions into account when checking if all patterns are covered by match expression. If all patterns are covered by match expressions, i.e. if I equal 0 is this, all patterns are covered by match expression. If match expression covers all patterns, if I equal 0, then you print this. I is greater than 0, then you print greater than 0. But this won't happen because a number is a UI integer and I can when checking if all patterns are covered by match expression. All patterns are covered by a pattern are these, expression are this. So this expression covers all the patterns. Non-exhaustive patterns not covered. Note the matched value is out of type. Pattern 0 to equals to max, not covered. Match arm with guards don't count toward exhaustivity. Ensure that all possible cases are being handled by adding a match arm with a wildcard pattern or an explicit pattern as shown. 0 and including max. Indirectly accessing variable makes it impossible to branch and use that variable without for binding values to names. Indirectly accessing a variable makes it impossible to branch. Indirectly making accessing a variable and use that variable without rebinding. Match provides at sigil for binding values to name. Would match 1 to 12 directly, but then what age would the child be? I'm a child of age. Instead, bind to n for the sequence of 1 to 12. Now the age can be reported. If the value lies between these two, and then record nothing bound, return the result. Function age which returns can also use binding to destructure enum variants such as options. Sum42, some number you call this. If this returns sum 42, you match any other value, return this, match anything else, you return this. Yeah. So we are nothing but just raw pointers. Dealing with raw pointers, we are doing this in the unsafe block because of raw pointers. If it only allows you to do 5 additional things, note that unsafe block does not turn off rust safety checks, it only allows you to do 5 additional things. What does that mean? We use the you can take 5 actions in unsafe rust that you can't in safe rust, which we call unsafe superpowers. Those superpowers to dereference a raw pointer, cool, call an unsafe function or method, access or modify mutable static variables, Mutable static variables. Nice. Implement an unsafe trait for Okie I don't know what that is. Access fields of an union. Huh? To access fields of a union, I need unsafe. If you use a reference in unsafe code, it will still be checked. So we want to minimize the use of unsafe code, for example, running our kernel, creating boot image. We need this to create boot image. Okay, so why do we need to create a boot image? To turn our compiled kernel into a bootable disk image, we need to link it with the bootloader. So you have an image like kernel image, which is your like sort of your application code if we are concerned with bootloader. mm, I don't know if that is a correct term, but this code doesn't have any information to set up the hardware, right? It doesn't concern with that. It just manages resources of. So we need to link it with bootloader, as we learned in the section about booting. The bootloader is responsible for initializing the CPU and loading a kernel. So see, the initialization code goes into bootloader, so that's why we need a bootloader. Instead of writing our own bootloader, which is very fun to do, we'll do it sometime, which is a project of on its own. True, we use bootloader crate. This crate implements a basic BIOS bootloader without any C dependency. That is a very good part. Just Rust and inline assembly. I want to see what that inline assembly looks like. Oh, repository. How does that look like? Environment variables, so you are pulling it in from there. That sidetrack Rust learning took a lot of time out of my stream. It's good, I guess. So yeah, I was about to look the inline assembly. GPT. We'll see. Remember guys, this post is compatible with 0.9, but I was struggling with this thing to compile it with that. Let me show you. And here you have to um like let me just you see the bootloader 29. This is important. 23 will not work. So make sure to remove this to if you put anything like this in here, don't do that. Now there's one thing I want to do, which is not the theme's topic. How do I create a new thread? Control I. Anything. Start tmux from 1 instead of 0. That give it enough context to give me an answer. Base index. Set g base index. Renumber windows. Ensure window index number gets reordered on delete. Okay. Base index, chain index. Okay. So this is tmux.config. Where is it? Inside. Where is tmux config file? Primary location is this is can it be in dot config? Minimal file can be placed on this while the default location for the user is this. You can also create a config tmux config code. Specifically at NFI GTMU. Oh, which is tmux.config, right? How do we restart current tmux session? This won't work probably. It did. Okay, moving on to this thing. Creating a boot image. So after that, we just install this and So how does it work? Boot image create tool performs the following steps. It compiles our kernel to an ELF file. Cool. It compiles the bootloader dependency as a standalone executable. It links the both of them. Cool. Okay. When booted, the bootloader reads and parses the appended ELF file. हमारी ही गलती है भाई. Yes. It then maps the program segments into virtual addresses in the page tables. Zero. Whoa, 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 whoa. Hold on, hold on, hold on. When booted, the bootloader reads and parses the banded ELF file. The bootloader reads and parses this file. It then maps the program segments, so the program has segments, okay, to virtual addresses in the page table. Zeros the BSS section and sets up a stack. This thing is different. This thing is different. This thing is different than your embedded bootloaders because they don't have. Finally, it reads the entry point address, which is this thing, and jumps to it. Booting it into QEMU, you can do this. Boot it. I'm not doing it on real machine. These things that we can use cargo, we just have to put these things in here. Just a simple copy paste. What next is VGA text mode. Where am I in the VGA text thing? What is my last comment? Printing. So I'm done with the printing part also, which is I think I'll pick up from here tomorrow. Tata. See you. Meet you all tomorrow. Bye bye. Good night.